Hello everyone. So today we're discussing about thermal properties of matter. So let's begin. This is our chapter 7 of our CBSE class 11th physics. So first comes what is temperature? Temperature is the measure of degree of the hotness or coldness of a body, and heat is the form of energy transferred between two systems or system and surroundings. Okay, guys, I hope you understand what I am trying to say. Next, guys, we are discussing measurement of temperature. Temperature can be measured by the thermometer. The relation between Fahrenheit scale and Celsius scale is T minus 32 is by 180 is equal to Tc by 100. Here, here Tc is temperature of Celsius scale and Tf is temperature of Fahrenheit scale. You should note that Tc is Celsius temperature and Tf is Fahrenheit temperature. Next, guys, we are discussing ideal gas equation. Ideal gas equation is PV is equal to nRT, where P is equal to pressure, V is equal to volume, G is equal to gas, R is equal to gas constant, N is equal to number of moles of gas, and T is equal to temperature. So, guys, you can note down some of the following points. Next, guys, we are discussing thermal extension. There are three types of thermal extension: linear, superficial, and volumetric. You can see the three types of linear, superficial, and volumetric expansion, where dx by delta x by x is equal to alpha delta t, delta a by a is equal to beta delta t, and delta v by v is equal to gamma delta t. Next, guys, we are discussing relation between alpha, beta, and gamma. We can see that relation between alpha, beta, and gamma is nothing but y is equal to alpha by 3 into is equal to beta by 2. You should note down this point. Specific heat capacity. Specific heat capacity is the amount of heat absorbed or released to change the unit mass of the substance by 1 unit of temperature. You should note down this also. S is equal to delta Q by delta T, which gives small s is equal to capital S by M is equal to 1 by M delta Q by delta T. So, delta Q is equal to ms delta T. Next, guys, we are discussing calorimetry. The measurement of heat is called calorimetry, and the device used in this process is called calorimeter. Change of state. So, guys, next we are discussing solid, liquid, and gas state change, which is given in this chart. Solid to liquid is melting, liquid to solid is fusion, solid to gas is sublimation, and gas to solid is frosting, gas to liquid is condensation, and liquid to gas is evaporation. You can note this also so that you don't have any problem in anything. Next, guys, we are discussing latent heat. Latent heat is the amount of heat transport between a substance and its surrounding when it undergoes a change of state. Here Q is equal to ml, where Q is latent heat and m is mass and L is latent heat specific constant. So here you can see temperature to heat of water at 1 atm, where we are showing you the temperature to heat relation in a graph. Here the phase change is shown by not changing the temperature, but this is latent heat applying. Next comes heat transfer. Heat transfer is also of three types: conduction, convection, and radiation. Conduction applies for solids, convection for liquid, and radiation for gases. Next comes Newton's law of cooling. This is very important. It is very important. So, minus dq by dt is equal to kt2 minus t1, where dq is equal to the specific heat and dt is time in temperature, small change in temperature. K is specific constant depending on the area and nature of the surface of the body. So here comes the equation. The equation is T2 minus T1 is equal T2 is equal to T1 plus C dash e to the power minus kt. Okay guys, thanks for watching. Like and subscribe to our channel so that you don't miss any of our videos. Thank you.